This is going to be our flipped classroom on bonding. This is going to take several videos to get through, so this will be the part one of the bonding video. So first let's start with the concept of what actually is a bond. Well, when we talk about a bond, what we're talking about is an attraction between the protons of one atom and the valence electrons of another atom. And this is why bonds form, is that they attract each other. But the question is, why don't the atoms just mind their own business? They already have protons and electrons. Why do they feel the need to bond to other atoms? Well, there are two main reasons. The first is to become stable. Chemically speaking, most elements are unstable. They need to become stable, and the definition of stable in chemistry is usually forming what's called an octet of valence electrons, or 8 valence electrons. Now, not every atom forms 8. We'll get into the exceptions later. But most atoms are trying to get a full set of 8 electrons, and only the noble gases have 8 valence electrons. So atoms will do whatever they can to either gain or lose enough electrons so that their outer shell has 8. The second reason is that they want to lower their potential energy. Atoms, generally speaking, have too much energy, and by forming these bonds with other atoms, they then lower their energy and become more stable. So they kind of go hand in hand, lowering energy and becoming stable. Now, I want you to also note that that means anytime a bond is formed, it will be an exothermic process. Energy will always be released. And anytime you break a bond, well, that will require energy, so that will always be an endothermic process. So now let's talk about the different types of bonds. The first type of bond I want to mention is called ionic. Now, you might recognize in the term ionic the word ion. Ionic means a transfer of electrons. That is the definition of ionic. And when an atom transfers its electrons to another atom, specifically we're talking about the valence electrons, one of the atoms will then become a cation, which is a positive ion, and the other one will become an anion, which is a negative ion. So if the element gives away electrons, it now has a surplus of protons compared to electrons, so it's positive, and the one that gains it now has extra electrons, now that one is negative. And as you might expect, once you form these two ions, plus and minus, they then attract each other. And that is what an ionic bond is. And that is considered a very, very strong bond. And the second type of bond has two names. It's either called covalent or molecular. And this one is just a matter of sharing electrons. There's no transfer here. They just share the electrons between the two atoms, and that is also a bond. That bond is not as strong as ionic, but it does result in a very strong structure. And then finally, the strongest type of bond is technically called metallic. And as you might imagine, metallic bonds occur with metal atoms. But it's not between different metal atoms, it's the same metal. And what happens is the metals just let their valence electrons roam around the entire structure. And that's why it's called a sea of mobile electrons. Or another way to say it is they're delocalized electrons. And what happens is, since the electrons continually circulate around the entire structure, and I'm talking about even if that piece of metal is a mile long, the electrons from one end will travel all the way to the other end and back. This causes the metal ions to attract between itself and those valence electrons constantly, and that is the strongest type of bond that exists. So now what I want to do is I want to get into more specifics. I want to talk about ionic bonds. Well, first of all, when will you see an ionic bond, this transfer of electrons? Normally, it is between a metal and a nonmetal. That's going to be most of the situations. So let me show you how it works with these simple examples. Let's take the atom sodium. Na has 1 valence electron, and Cl has 7 valence electrons, and I've shown this with dots. And in case you're wondering, wait, how did I know this is true? How do I know Na has 1 and Cl has 7? Let's go back to a previous lesson. Remember we said, if you look in the periodic table of elements, anything in group 1 has 1 valence electron. Anything in group 17, like chlorine, has 7 valence electrons. Or you'd have to draw out the SPDF structure, and you see for yourself how many outer electrons there are in that shell. Another way to do it is simply to count. If I realize that this is the third period, Na is in the first box, it has 1 valence electron. Let's see where Cl is. It's on the other side, so it's 1, 2, 3, 4, 5, 6, sure enough, 7. So, the next thing I want to show you is that sodium is going to become +1 and Cl is going to become -1, which means sodium is going to lose that 1 electron and Cl is going to gain that 1 electron. Again, you might ask the same question, how do you know this? Well, once again, you have a cheat sheet here if you want. If you look in the upper right-hand corner of sodium, it tells you, yep, sodium is going to become +1. And for chlorine, even though it has many options, the one that is the most common, the one that's going to happen is up here. Chlorine is going to become -1. So now that I know that, I can see that sodium becomes +1 and Cl becomes -1. There is our bond. That is what sodium chloride looks like. Let's try another one. I want to combine magnesium with oxygen. I'm not going to go back to the reference table. I'm going to assume you can do this on your own. Magnesium has 2 valence electrons and oxygen has 6 valence electrons. Well, no surprise there. When you look at the reference table, it says that magnesium will become +2. And what does +2 mean? It means you're losing these 2 electrons. What does -2 mean? It means you're going to gain them. So there we have magnesium with oxygen forming magnesium oxide. This is how you show the ionic structure. Now let's try a trickier one. Let's try to combine magnesium with chlorine. Now the problem we're going to have here is that magnesium has 2 valence electrons and chlorine has 7. And magnesium, according to the reference table, must lose both of them. It doesn't have an option of just losing one. It's got to lose both. But chlorine can only gain one. You can see here there's only one spot open. So how can we combine magnesium with chlorine? There's only one way. If the magnesium gives away 2 electrons to 2 chlorines, and that each of the chlorines accepts one of the electrons, which means we get Mg plus 2, Cl minus 1 with 8 dots, and another Cl minus 1 with 8 dots. And now everyone is happy. Everyone has their octet. But that means that the formula for magnesium chloride is not MgCl, it's MgCl2. This is the formula, but this is how you'd write the electron dot or Lewis dot structure for the ionic compound magnesium chloride. Now, I want to talk about the last part of this lesson, which is determining an ionic formula. And determining ionic formula is what we just did. It's finding the atoms and then making sure that they match up. But as we just saw, sometimes it's not a 1-to-1 relationship. Sometimes it's 1-to-2, or it could be something else. So how do you figure it out? Well, you could do what I just did with magnesium chloride, but there actually is a simpler, faster way to do it. So I pose this question, what is the chemical formula for sodium oxide, which is a combination of sodium, Na, and oxygen, O? There's a method called the drop and switch method, which says take the charges that are in the reference table, forget the pluses and minuses, just look at the numbers, and drop them and switch them to the opposing atoms. So let me show you how it works. When I look up Na in the reference table, it says Na is a +1, and when I look up O, it says O is a -2. Or more accurately, that's what they're going to become once they lose and gain their electrons. So all you need to do is take this 1 and bring it down here, and take this 2 and bring it down there, and that's going to become your new formula. So 2 NAs and 1 O becomes Na2O. It's that simple. And again, don't worry about the charges. It's not that the charge of sodium is a -2. It isn't. The charge of sodium is still +1. There are just 2 of them. And if you think about it, that makes perfect sense, because if you need to cancel an O -2, wouldn't you need a +2 to cancel it? But sodium is not +2, it's only +1, therefore I need 2 of them. 2 times 1 is 2, cancels a -2. Let's try a more complicated one. I want to combine aluminum with sulfur to make something called aluminum sulfide. Now, according to my reference table, aluminum is a +3 charge and sulfur is a -2. So take that 3, bring it down there, take that 2, bring it down there, and that formula becomes Al2S3. Again, we're not drawing the electron dot structure. I would have to draw 2 Al plus 3s and 3 S minus 2s on the same piece of paper, and remembering to put all the dots in for the sulfur. I'm just showing the formula, Al2S3. So, do you always drop and switch? No. There's one time when you don't bother drop and switch, and that's when the numbers already cancel each other out. So, for example, if I want to combine calcium with oxygen, Calcium is a +2, or rather will become +2, and O will become -2. There's no reason to bring the 2's down. +2 and -2 already cancel each other out, so the formula is just CaO. It's a 1-to-1. So only do the drop and switch when the numbers don't match. And finally, let's apply this same concept to something called polyatomic ions. So first let me show you what the polyatomic ions are. They're in your reference table on table E, and there's a list of, I think, about 25 of them, and here they are. What these are structures that have charges. You can see each one is either positive or -2, but they're not one single atom. They're not monoatomic. They're polyatomic. They're multiples. So what happens if I have a compound like potassium nitrate? Remember I told you earlier that metal and nonmetal combinations form ionic compounds? Well, the formula for potassium is K, or K+, and that is clearly a metal. And nitrate, if I look in my reference table, there it is right there, is NO3 with a -1 charge. It's a polyatomic ion. Well, the same rules apply. Since this is a +1 and this is a -1, they cancel, and your compound is just KNO3. But what if they don't cancel? What if I try to make the compound sodium carbonate? Well, again, sodium is Na, and according to the reference table, it's +1. Let's see what carbonate is. Carbonate is right there. It is CO3, but it has a -2 charge. Okay? So what do I do when the +1 and the -2 don't match? Drop and switch. I'm going to bring the 2 down there. I'm going to bring the 1 down there. So it's going to become Na2 and then 1 CO3, so just CO3. I'm not going to put a 1 here. There's no point. I mean, I'm saying there's one of these polyatomic ions. You could put it in parentheses if you wanted, but there's no real reason to. It's 1 CO3 ion, even though it has parts in it. Now let's try a really challenging one. Magnesium phosphate. Magnesium is a +2 ion, and phosphate, according to the reference table, is a -3 ion, and its formula is PO4. So I have Mg +2 and PO4 -3. How am I going to make that work? Well, again, I'm going to take the 2, bring it down there, take the 3, bring it down there. So it becomes Mg3, but then I need to put 2 after the PO4. Well, here's the problem. If I don't put parentheses around the PO4, it's going to look like PO42. I need to show that there are 2 phosphates, 2 of these, the PO4s. So the formula becomes Mg3PO42. And that is how you do the drop and switch method for both monoatomic and polyatomic ions. And that is our first lesson on bonding and ionic compounds.